Namaste. Welcome to this channel, Chemistry Made Easy by Dr.ARM. We were discussing theories of acids and bases. So last time we have seen the introductory, in short, the difference between variety of theories that are associated with the chemistry of acids and bases. But here we are going to see only the major concepts of acids and bases, because there are several minor concepts and which are not applicable at today's modern times. But the other theories which are not applicable even today can be discussed and understood also. So first of all, we will see what are these major acids and bases. These acids and bases are, first, this Arrhenius theory, Arrhenius concept. This Arrhenius concept was proposed earliest in 1894, as we have seen last time. But the study was carried out in the years before that, that is between 1880 to 1890. And the theory or concept was also related to his PhD work, and because of the importance of this theory, he was awarded Nobel Prize in Chemistry in 1903. So this was very important award for Arrhenius for his proposal of this concept. According to his concept, the acids, Arrhenius acid and his base. So the acids, as per his concept, are the substances which when dissolved in water, produces H plus ions. Now we can see the example, say like HCl. So when this HCl is dissolved in water, it produces this H plus ions. So there is no need to show this solvent, but this is for our convenience. So instead of this, we can show this as aqueous. So when HCl is dissolved in water, it is represented as this. So after this, it dissociates into H plus aqueous plus Cl minus aqueous. So similarly, we can have HNO3. When HNO3 is dissolved in water, it releases H plus ion. So it produces H plus ion, aqueous, and NO3 minus. Similarly, H2SO4 also undergoes ionization into H plus and HSO4 minus. Or we can say twice H plus and SO4 2 minus. So similarly, we can have a number of such examples. Even we can consider the organic acids such as acetic acid, CH3COOH. When dissolved in water, it dissociates into CH3COO minus plus H plus. These are also aqueous ions. So the acetic acid HCl, HNO3, etc. have tendency, when they are dissolved in water, they have tendency to release H plus, and that is why they are called Arrhenius acids, or according to Arrhenius they are defined as acids. Similarly, we can have the bases. We can have the bases. So these are the substances which when dissolved in water produces OH minus ions. Produces OH minus ions. So we can show the examples such as NaOH. Aqueous means when dissolved in water undergoes ionization to produce Na plus and OH minus. So these are also aqueous ions. Aqueous means they are present in water. So similarly we can show KOH, calcium hydroxide, or any other hydroxides of metal ions. So which are having tendency to release OH minus ions. So because of this capability to release OH minus in water, so they are called bases. So we can have number of such examples of bases. Then we will see their acidic and basic behavior. So if we carry out the neutralization reaction. So we can show the reaction like this. So for example, if we use HCl plus NaOH, so these are aqueous in medium. So as a result of this, we will get this H plus and OH minus. So it will produce H2O plus Na and Cl, that is NaCl. So here in short, we can see that when acid reacts with a base in water, gives solvent, that is water, and a salt. So this is called a neutralization reaction. So here acid reacts with base to produce salt and solvent, that is water. So here this water is undissociated. So this is called a neutralization reaction. This is also a characteristic reaction of the acid-base nature. So this theory has also certain limitations. So what are these limitations? For example, we can consider the substances like so here if we consider the substance like say NH3, so this has no OH minus ion, but still when it is dissolved in water it produces NH4 plus and OH minus. So this is the base, but it has no OH minus ion. Similarly, there are also other acids like say BF3, so which can react with this is acid, so it can react with a base like NH3. So it produces the compound like NH3BF3. So the acid plus base gives this addition product. So there are number of such examples which show that this definition which is given by Arrhenius is not convenient to define every substance as acid or base. So this another limitation. So this is one limitation. Another limitation is that this theory is applicable only to the reactions or substances when dissolved in water, but it is not applicable to non-aqueous solvents where the water is or H plus is not easily available. Third thing is that this theory also fails to explain the acid-base behavior of gaseous and solid substances. So they cannot produce the H plus and OH minus ions. So there are such number of limitations. But this theory is very easy to apply, and conveniently this can be applied to simple acids and bases. But in order to consider the limitations and overcome these limitations, we have to use another theory, and the next theory is Bronsted-Lowry theory. Bronsted-Lowry theory or concept. So this is a relatively better concept than Arrhenius concept because it covers some of the limitations of Arrhenius concept, and therefore it is said to be relatively superior theory to Arrhenius concept. According to this theory was proposed in 1923, which we have seen already. And according to this, the acid and base can be defined. So according to this concept, the acid is a substance which has tendency to release proton or donate proton. Acid is a substance which donates H plus, that is a proton, and here base is a substance which accepts H plus ion. So this is very simple concept, and in short we can also say that the acid is a proton donor and base is a proton acceptor. And according to this theory, it covers the substances which do not have these H plus or OH minus ions, even though they are considered to be the acids and bases. For example, if we consider the substance like say HCl, so this HCl can donate proton, that is H plus and Cl minus. Similarly, this is a substance which can accept a base is a substance which can accept proton. For example, if we consider NH3, so this can accept a proton, that is H plus, and gives us NH4 plus ion. And because of this, the theory is superior. So here, the theory also gives another concept. So on this basis, the theory also provides another concept of this conjugate pair of acids and bases. Conjugate pair of acids and bases. So this pair is nothing but the substances having the difference of H plus only. For example, if we consider here, we can take the simplest example when we consider water and if it undergoes self-ionization. So we can say that H2O plus H2O gives here H3O plus and OH minus. So here you will find that there is self-ionization. Water molecules undergo self-ionization. So we can consider one of them as acid. say if we consider this as acid, this as a base, then after losing its H plus to this H2O, it is converted into this OH minus. So if we label this as acid 1, it is base 1. Then this H2O is a base because it accepts proton from this water. So this is a base and it is converted into H3O, which is acid. So this is acid 1 and this is base, this is acid 2 and this is base 2. So in this way we can get conjugate pair. Acid 1, base 1 is one conjugate pair of acid and base. Similarly, base 2, acid 2 is another pair of conjugate acids and bases. Similarly, we can have another example. Say if we consider the NH3, if ammonia also undergoes self-ionization, then it is converted into this is air, if this is acid. So it will release proton to this NH3 and it is converted into NH2 plus, and here it is converted into this NH4, NH2 minus and NH4 plus. So here by removal or transfer of this proton, so proton is transferred from this acid to this base, there is transfer of this H plus. So we can get this. So there is formation of this base. So from this acid we get this base. So this is base 1, this is acid 1. And from this base we get this acid. So this is acid 2 and this is base 2. So this acid 1, base 1 is one pair of acid base, that is conjugate pair. This base 2 and acid 2 is another conjugate pair of acid and base. So in this way we can have number of such ion pairs. Further, this theory can also explain this superiority, or we can say this enhancement of the strength of the acid and base. So if we say acetic acid is added to water, it behaves like a weak base. But when this weak acid is this acetic acid is added to another solvent, that is a non-aqueous solvent, then it behaves like a stronger base. So the strength of acid or base depends upon the nature of solvent. So some acids and bases are stronger in water, that is aqueous medium, and which are also further relatively more stronger in another solvent like ammonia. So for example, if we consider the HCl, for example, if we consider HCl. So HCl is already stronger acid in water. But when we add this HCl to ammonia, that is NH3, it becomes still more stronger acid. Here it means when we change the solvent, the strength of the acid or base is either increased or decreased depending upon the nature of solvent. So if we say the stronger acid is placed in a stronger base, then the strength of acid is enhanced. And in other words, if we say the stronger acid is added to a weaker base or weaker other substance, weaker base, then also the strength is relatively less increased, but there is increase. So acetic acid is stronger in organic solvents, but it is weaker acid in aqueous medium. So this is the change in the strength of the acid. So this theory is, this concept is also explained very well by this Bronsted concept. So we will discuss any other examples next time also. So till then, goodbye. See you next time. Please subscribe to this channel and press bell icon and like button. So thank you very much.